This is the notes video for section 1.8, slides 47 and 48. All right, so we're given y equals 3x squared minus 10x plus 2. Find y prime at x equals a. All right, so remember that y prime means we're finding the slope of the tangent line. All right, and so we are going to use our limit as h approaches 0, right? All right, so limit as h approaches 0 of. All right, so remember, we're plugging in a for x. So we have 3a plus h squared minus 10a plus h plus 2, right? That's f of a plus h minus f of a. So that's just going to be 3a squared minus 10a plus 2. All right, and then divided by h. All right, so now remember that you could have done this with x instead of a, and then you plug a in at the end. All right, and then when we do the next example, we're going to do the same thing. Well, with 3. But remember, if we do all the work with a, then we can just plug 3 into the final result. All right, so let's see, limit as h approaches 0. All right, so we need to expand this out. So remember, a plus h squared is a plus h times a plus h. So that's going to be a squared plus 2ah plus h squared. So now I'm going to distribute the 3. So 3a squared plus 6ah plus 3h squared. Then I'm going to distribute the minus 10. So minus 10a minus 10h plus 2. And then I distribute the minus sign. So minus 3a squared plus 10a, and then minus 2. All right, so very important that you remember that everything without h must subtract out at this point in the problem. All right, and if it doesn't, you've made a mistake. All right, so 3a squared minus 3a squared, so those do in fact subtract out. 10a, sorry, minus 10a plus 10a, good, plus 2 minus 2. So now you'll notice everything else has an h. All right, and so I'm going to carry that down. So limit as h approaches 0, 6ah plus 3h squared minus 10h, all divided by h. And so now if everything without h has subtracted out, that means now I can factor h out of all of the remaining items so that it can reduce. All right, so h times 6a plus 3h minus 10, all divided by h. So h reduces, and I'm left with the limit as h approaches 0 of 6a plus 3h. And so then you evaluate h equals 0, and you get 6a, right? So y prime evaluated at x equals a is 6a. All right, so now the next question says, what is y prime at x equals 3? So y prime evaluated at x equals 3, well, very simple. You just put 3 in for a. So 6 times 3 gives you 18. So remember, what does 18 mean? It means the slope of the tangent line to this graph of y at x equals 3, right? That's what 18 is. All right, so that's slide 47. All right, and then slide 48. All right, write the equations of the tangent and normal lines at x equals 3. All right, so remember, tangent, normal line. So what do we need? We need a point and a slope. All right, so point. All right, so remember the point is going to be 3 comma what? Well, it's going to be y evaluated at x equals 3. So now we're plugging 3 in to that original equation. All right, so remember the original equation, 3x squared minus 10x plus 2. So 3 times 3 squared minus 10 times 3 plus 2. All right, so 3 times 3 squared, so that'd be 3 times 9, 27, minus 10 times 3, so 27, minus 30 plus 2. All right, so 27 minus 30 is negative 3, plus 2 is negative 1. So my point is 3, negative 1. All right, and so now the slope of the tangent line we just figured out was 18. And so we have y minus negative 1 equals slope of 18 times x minus 3. All right, and then the equation of the normal line would be y plus 1 equals negative 1/18th. Remember, the tangent line and normal line are opposite reciprocals. They're perpendicular. All right. And then x, excuse me, sorry. And then x minus 3. All right. So that's example 6. All right. So now the next one is kind of an introduction into this thing that we will hit much more later in the year, but I want to introduce it here. All right. So it says, here's the graph of f. Sketch the graph of f prime. All right, so remember, if this is a graph of f, you need to remember f prime is what? So remember, f prime is the slope of the tangent line. All right, so I'm going to highlight a number of points on this graph. All right. All right, and so what we want to do is we want to think about the slope of the tangent line at each one of these points. All right, so let's think about it. All right, so if I were to draw on a tangent line right here, there would be some positive slope. Now I'm not thinking about like the number necessarily. I'm just thinking about the value, right? So it's going to be a positive number, right? Now, if I draw in the next tangent line, this is also going to be positive, but it's going to be a smaller positive. So I'm going to put a smaller positive number. All right, then when I get to the top here, it's actually going to be a horizontal line. So that would be a slope of 0. All right, not theta. I don't know why that happened. All right, so 0. All right. And then here we have a negative slope, right? So we have a negative, right? Then this one is a bigger negative slope. And then this one would be a lesser of a negative slope. So, right, so we have a negative slope, then a steeper negative slope, and then a less steep negative slope. Then down here, we're back to a 0 horizontal. All right, then here we have a positive slope, and then here we have a even bigger positive slope. All right. So remember, f prime is the slope of the tangent line to f. So now let's say that I was sketching a graph. All right. So I'm going to draw some axes here. All right. And I'm going to kind of like put, uh, I'm going to put a point here. Right. I'm going to put a tick mark there. All right, so now to the left of that tick mark, right? So that's at, I don't know, about like negative like 2.8. So let's say like negative 2.8. All right, what do you know about the graph of f prime? Well, you're going to have a positive number, right? And then a smaller positive, so that means closer to 0, right? Then at this negative 2.8, we have a 0, right? So that means f prime is going to touch or cross the x-axis. Then we have a negative number, a larger negative number. Then here we have a smaller negative number. Then once again at about, it's like at 0.8. So let's say 0.8. All right, we have another 0. All right, then here we have a positive number and then a larger positive number. And so this would resemble the graph of f prime based upon that graph of f. All right, so that